increase our capital by 100%, like 1 multiplied by 1, so we are getting 2 capital, and here also we are putting into 2 capital here. So both inputs were increased by 100%. Then what has happened to the output? If you are looking here, initially we had 100. For this case, we had 100. But this case, we are having 200. Likewise, if you increase by another 50% here, so it is becoming 300. Output also increased by 50%. If you increase another 25%, 3 into 4, and here also 3 into 4, our output also increased by 25%. So if you look at this table clearly, that says when we increase our production factors by certain proportion, both the production factors in this case, if you are having any number of production factors, if you are increasing all our production factors by a certain proportion, what happens to our output? That output also increase with the same proportion. In this case, in this table. So that can be explained with the concept called returns to scale, which I will be discussing later, but I just wanted to show you with this table. When we increase both our capital and labor with the same proportion, if it is 10%, both capital and labor will be increased by 10%. Then what happens to our output? Our output also will be increased with that percentage. If it is increased by, if both production factors increase by 10%, our output also will be increased by 10%. This is known as constant returns to scale, but the concept is returns to scale. When you enhance your scale, when you improve your scale, or when you increase your scale, what happens to your output? This is called returns to scale. That also can be easily identified with this table. I will be discussing that later because we need to discuss about the long run production function, which is not discussed yet. After that, I will be coming back to this returns to scale. But with this table, just look at 1, 1, it is 100, 2, 2, it is 200, likewise, right? Whenever we are increasing our scale by a certain proportion, our output also will be increased with certain. In this case, it is with the same proportion. In some cases, maybe more than that or less than that. I will come back later, but just remember the concept returns to scale. Other than that, if you look at this table, you can identify one more thing. That is, if you mix one capital, one labor, your output is 100, which says the conversion rate. When you mix your inputs with a certain proportion, then what is the output? Simply, if you put like, if you are mixing one capital and one labor, what is the level of output? It is 100. And if you are mixing 2 and 2, 200. So if you look at this number, and if you look at the number here, this is known as efficiency parameter. So I think I explained this with the function. Efficiency parameter means how efficient your production, how your conversion rate. When you mix one capital, one labor, what is the conversion rate? In this case, it is 100. If you are mixing 1 unit of capital, 1 unit of labor, your output will be increased with 100. That will say efficiency is 100 never. So we say it is the efficiency. So efficiency we discussed. Then the case, how we can increase the efficiency of a firm. It is very simple. If you are having a Cobb-Douglas production function, I mean technically not increasing efficiency in the production process, but in our methodological development, if you want to increase the efficiency in a Cobb-Douglas type of a production, just increase the A. Because if you remember, under Cobb-Douglas production function, we had the functional form, it was like this. Output is a function of capital and labor. So we said A times A K alpha, then L beta. So this is the functional form. Right here, we learned that this A stands for efficiency. Therefore, in a Cobb-Douglas type of a production function, if you want to increase the efficiency, simple thing is to do increase the value of alpha. Efficiency parameter. Right. I have done it here. So now you can see. Previously we had 100 here. Here we had, okay, yes. Here we had 100. Now we are having 200. And if you go back, so here, here we are having 100. So when we mix one capital, one labor, output increase with 100. In new case, when we put 200, the same functional form, then one capital, one labor, we are getting 200. In the previous case, when we had two capital and two labor, then output was 200. Now it is 400. And that depends on the value of this A. This is why it is known as efficiency parameter. If you change your efficiency, this will be increased. If you want to change that, just change the value of A. Thereby, we can increase the efficiency. Efficiency, as I explained it previously, but anyway, efficiency means how we can increase our output level without changing the level of inputs. We are having the same level of inputs. If we mix like 10 capital and 10 labor, our output also will, if we mix 10 capital and 10 labor and our output is like 100, in the same way, if we are mixing 10 capital and 10 labor, if our output is 150, then we say there's an increase in efficiency because we are efficient. We are having the same input level, but our output is higher than that. Then we call that as the increase in efficiency. That can be done by changing the efficiency parameter, which is A in a Cobb-Douglas type of a production function. So remember that too. So here I have what I have done. I have calculated all these places. You can see all the places we are having double the previous table. That is because we have double the efficiency. Previously it was 100. Now we have increased that to 200.